All right, so let's have a look at a polynomial of degree 3, which is, I guess, intuitively called a cubic graph. All right, so a cubic graph is any polynomial function where the highest degree of our pronumeral is 3. So ax cubed plus or minus something. All right. Now a positive cubic graph has got the shape of we have on the bottom left, our negative cubic. So I guess a positive cubic graph, positive suggesting the whole thing's increasing the whole way. So as x gets bigger, use a different pen, I think. As the function, as the x value gets bigger, the function value gets bigger. Okay, a negative cubic graph, as the x value gets bigger, the function gets bigger negative, so it's decreasing in size. All right. In terms of sketching them, I think the easiest way to get a nice shape is do half a parabola up and then do half a parabola down. Right. Now they're not parabolic; they've got a similar shape, but that just gives you a nice feel, a nice look at the graph. All right. The point, whereas our parabolas would have what we call a turning point or a stationary point, the vertex, our cubic graphs have a point of inflection. All right. And so similarly with a turning point, the gradient there is 0. All right. So we call that origin point there the point of inflection. Right. The domain, if we look at the graph, well, there's no number that we can't cube. So the domain of the graph is R, and the range of the graph is also R. Right. So as you would expect, we can translate these graphs left, right, up, down, reflect them, turn them upside down, all those sorts of things. Yeah. So similarly to our quadratic graphs, an x minus h inside the bracket. All right, so if it's an x minus h all cubed, well, we're going to shift this graph to the right, h units. If we have a plus or a minus k at the front, so obviously a plus k, we're going to move it up k units. So outside of the bracket, it's going to move it up and down. Inside the bracket moves in left and right. Exactly the same as our quadratic graphs. If the a value out the front, as I said previously, if the a value is negative, we flip it upside down. All right. So we've got our horizontal translations, we've got our vertical translations. All right. So there's the general rule, which really applies. It's no different to our quadratic general form. Let's look at a few graphs. All right, sketch the following graphs stating the points, what do we have to state? Showing coordinates of intercepts at the point of inflection. All right, so first thing we know, so, and even if you have to, you do just a little quick sketch of, all right, that's my basic shape there. All right, that's my basic shape. Now what's happening to it? Well, it's shifted across 2 units and it's shifted up 4 units. So what are we going to do? Let's work with, we'll do those as 4 and 8. Okay? So 2 units across would be there, 4 units up is there. So there's my point of inflection. Oh, sorry about that. Now, whereabouts is my intercept? Well, let's just get our intercept first. Let's get our y-intercept. So y-intercept, if I put x equal to 0, I get y is equal to negative 2 cubed plus 4, which is negative 8, plus 4, which is negative 4. So my y-intercept is there. So in actual fact, it's quite a steep graph, isn't it? So let's do a downward parabola through there, and then we're going to do an upward parabola there. It's not a great join there at the middle, but there's approximately what our, in fact, that second part probably should be a lot steeper. So it's quite a narrow, steep graph, all right? That point of inflection we just decided was at 1, 4 because we 2, 4. Shifted across 2 and up 4 units. The only other thing we need to now find is our x-intercept. So we've got our y-intercept, x-intercept. We put y is equal to 0. So I get 0 is equal to x minus 2 all cubed plus 4. Negative 4 is equal to x minus 2 cubed. Now we can take the cubed root or the odd powered root of any number, positive or negative. So for example, the cube root of negative 8 is negative 2. Negative 2 by negative 2, positive 4 by negative 2, back to negative 8. So I get the cube root of negative 4, and then I add 2, and that's equal to x. So that's my x-intercept. So that's 2 plus the cube root of negative 4. And I might just, instead of rewriting it, I'll bring it across there. Okay, so we've got showing coordinates. So always, if it says show coordinate, let's put coordinates in. So 0, negative 4 for my y-intercept, 2 plus the cube root of negative 4 for my x-intercept, and we've got a point of inflection of 2, 4. All right. What have we got in here? So for B. So let's rearrange it so it looks like the way in which our graphs normally look like. 2, okay, all cubed, and then I've got that plus 2 that I've brought across. Now, what I want you to do is, let's write the coefficient of x is always positive 1, okay? So if I take a little negative x out the front there, that makes that a minus 1 in here. So just check that. The negative times x is negative x. Negative times negative 1 is positive 1, which is the same as 1 minus x. So that's really clear now. Out the front is what we call our dilation. So that makes our graph fatter or skinnier. So in this case, skinnier. Negative inside, we're reflecting it about the y-axis. Okay, so everything on the top right is now on the top left. Minus 1 inside, we shift it to the right 1 unit. Positive 2 outside, we shifted up 2 units. All right. Now, so I guess the key one is there, with my point of inflection is at the point 1, 2. So I'll change my, now let's have a look. So point of inflection at the point 1, 2. Let's get an x-intercept. Actually, we'll get y-intercept first, it's a bit easier normally. The y-intercept, if I put x equal to 0, I get y minus 2 is equal to 2 times 1 minus 0 all cubed. So that's just 1 cubed, which is 2. So y is equal to 4. So I get the point 0, 4. All right, so let's put a few of these points in. So we've got our point 0, 4. Whoop. Got our point 0, 4 there. I've got the, so that's going to be 2, 2, point 1, 2. There's my point of inflection at 1, 2. So if my graph is normally like that, so what's happening? So it's been shifted across, that point's come across 1, up 2, and it's been reflected. So it's going to look a bit like that. Yeah. So I'm thinking my x-intercept will be down here near positive 2 somewhere. So let's work out that x-intercept. So if I put y equal to 0, we put y equal to 0, I get negative 2 equals 2 times 1 minus x all cubed, divide by 2. Negative 1 is equal to 1 minus x cubed. Take the cube root of negative 1, which is negative 1. 1 minus x. Take the x across, so make it a positive, bring the 1 back on the other side. I get 1 plus 1, which is 2, which seems to actually fit quite nicely, doesn't it? So again, so let's try and, there's my upward parabola. There's my downward, just to give it a nice shape. Probably shouldn't use the term parabola. Mark in my point. We said it was the point 1, 2 for the vertex. Intercept was at 2, 0. and I've got 0, 4 marked already. All right. So it's just exactly the same process. Just get a feel for how everything's working. Number 3, let's divide everything by 2. So I get y is equal to -1/2 x minus 1 all cubed minus 2. Everything gets divided by 2, yeah? So now clear cut again, dilation of a half, so it's going to be a bit fatter. Negative, it flips upside down. 1 unit to the right, 2 units down. All right, so first things first, we know that point of inflection. Point of inflection is at the point 1, -2. So I'll use the same scale, I think. So 1 across, down -2. Find our x and y intercepts. So if I put x equal to 0, I get 2y is equal to -1 times 0 minus 1 cubed minus 4. 2y is equal to -1 times -1 cubed is -1. So I get 2y is equal to 1 minus 4, which is -3. So y is equal to -3 on 2. So where's -3 on 2? It's that's -1, so it's going to probably be there. Okay. See, what about an x-intercept? So let's bring an x-intercept over here. X-intercept, we'll put y equal to 0, so I get 0 is equal to -1, x minus 1 all cubed minus 4. I might take that whole expression across to make it positive. Again, we've already mentioned how we can get the cube root of a negative number and then add 1. So x is equal to 1 plus the cube root of -4. So let's think about the cube root of -4. So the cube root of 1 is 1. The cube root of 8 is 2. So the cube root of 4 is going to be somewhere between 1 and 2. And because it's negative, it's going to be a -1 point something. And the only reason I want that, so therefore we know our x-intercept is less than 0. It's a negative number, which fits in. So maybe it's around here somewhere. So again, there's my cubic coming through. And we can draw it down. Point of inflection we said was at 1, -2. That point we said was 1 plus cube root of -4, 0. And we've got the point 0, -3 on 2 there. So it said to label the coordinates, show the coordinates. So actually label the coordinates. All right? All right. So I guess an extension of that is what we call our cube root graph. So really y equals x to the power of a third is basically, if I cube both sides, the graph of x equal to y cubed. And so x equal to y cubed, well, it's a cubic graph, but about the x-axis. Yeah, so it's a bit like our square root graph, okay, where we have y equals the square root of x. So it's part of a parabola about the x-axis, with a plus or minus there, so it's accurate. So my x to the power of a third graph is a cube root function, which makes it a cubic graph about the x-axis. Everything else is the same. Coordinates of everything, vertical gradient. So the vertical gradient is basically where that point of inflection is. Where if I was to draw a vertical line touching the graph, and we'll talk about that later on in the course, we get a vertical line. So really that's my point of inflection. So 1 unit across, 2 units down. So I'm going to go, and we'll do that. 1 unit across, 2 units down. And that's it. And so my graph is sort of a cube, so a bit parabolic like that, into a bit like that, something like that. Now I probably should have found some intercepts first, but let's check. if I put x equal, sorry, we'll put y equal to 0. No, I won't. I'll put x equal to 0. We'll do both. I've got y equal to -1 to the power of a third minus 2, which is just finding out the cube root of -1, which is -1 minus 2, so it's -3. No, that's not bad. 0, -3. Let's get an x-intercept, so put y equal to 0. I get 0 is equal to x minus 1 to the 1/3 minus 2. Take the 2 across. Now to get rid of x to the power of a third, we want to cube both sides. So that means that 2 cubed is equal to x minus 1. So 8 plus 1 is equal to x, so x is equal to 9, which wasn't very good at all. So let's just tidy up that one there. Should be a lot further along. So we probably won't be able to do it complete justice. So it's up here somewhere. 9, 0. Okay. So there's our cubic graph, our graph term. How do I want to describe them? Cube root graph. Finally, y is equal to negative out the front, x plus 2 to the power of a third plus 1. So again, what do we know? 2 units to the left, 1 unit up, and everything's reflected. So by reflected, what we're going to mean is that's my original cubic graph. And so if I'm going to reflect it, it means that everything on the bottom comes at the top. Okay, so we know that that's our basic shape, and we also know the graph has been shifted 2 units left and 1 unit up. So we'll call 2 units left and 1 unit up there. And so let's check some intercepts first so we get it roughly right. So what I want to do, I want to put x equal to 0. I'll get y minus 1 is equal to negative 2 to the power of a third. So y is equal to negative cube root of 2 plus 1. And again, the cube root of 2 is going to be slightly bigger than 1. So I'm going to have a negative, we've got negative y-intercept, so something quite small. And let's get our x-intercept. X-intercept, y equal to 0. So we'll get 0 minus 1 equals negative x plus 2 to the power of a third. Multiply both sides by a negative. 1 is equal to. Cube both sides, so 1 cubed is 1. So x is equal to -1. So I get the point -1, 0. So -1, 0 might be about there. So as a graph, it's marking our point of inflection at the point -2, +1, which was there. So there's my point of inflection. So we'll just get our nice into there and then bring it up through there. So point of inflection, what we say it was, -2, 1. X-intercept at -1. Y-intercept at 0, 1 minus cube root of 2. All right. Have a look at those and off you go.